In this video, you will learn how to perform algebraic operations with complex numbers. Up until this point of your mathematical career, you may not have learned about the number I, which is called the imaginary unit. But before we talk about that, let's warm up by evaluating some of these roots here. So up until now, if we were trying to take the square root of a -9, we would just say that this is not a real number. You're not able to do that. However, we can take the cube root of a negative number because, in this case, a negative times a negative times a negative will give us our -64. So the cube root of a negative is a negative. A fourth root of -81, on the other hand, is again not a real number because we can't take an even root of a negative. And the fifth root of 32 is 2 because 2 to the fifth is 32. So what you may have noticed is that we cannot take an even root. We don't write it, but there's a 2 there. We cannot take the even root of a negative number. But we can, because we're defining a new number called the imaginary unit, I, which is the square root of -1. And this is the number that when squared will be a negative. So when we take a look at the square root of -25, we actually can think of this as the square root of 25 times the square root of -1 and call this 5i. By the same token, if we want to think about a square root of -27, we might think of this as the square root of 9 times 3 times -1, and that would give us 3i, and we would have left over that square root of 3. Lastly, and this actually comes up a little bit later as well, when we multiply two radicals together, such as the square root of a and the square root of b, we can multiply the radicands. But there's a caveat there that says a and b have to be greater than 0. And so in this particular case, we cannot make this the square root of +12, but we can take the I out of each of these, so I root 2 and I root 6. Then we'll get I squared root 12. By definition, I squared is -1, so we'll have -1. I'm going to think of 12 as 4 times 3, so we'll get -2 root 3. So remember, if you're going to be multiplying, that you do have to take your i's out first. Now, these are all imaginary numbers that have the I, but a complex number are numbers of the form a plus bi, where a and b are real numbers. Now, if you think about what that's saying is a or b could be 0. So these are all examples of complex numbers. 2 plus 3i, square root of 2 minus 4i, 0 plus 5i, which we would probably just write as 5i, and 4 plus 0i, which we would probably just write as 4. So complex numbers may be real numbers, they may be imaginary numbers, or they may be a combination of an a plus bi, where a and b are both real numbers. So we do call, when we look at this, we call this the real part, and we call this the imaginary part. Okay, so what we want to be able to do, and the same thing we want to do with any set of numbers, is learn how to use them to add, subtract, multiply, and divide. So we're going to start here, and basically when you add or subtract, you're just going to collect like terms. So in this first example, these parentheses don't really mean much to me. So this is really 2 plus 3i plus 4 minus 5i. And if we collect the real parts, 2 and 4, we get 6. And 3i minus 5i is minus 2i. So we might get 6 minus 2i for that. On the second example, the parentheses are important because we know we need to distribute this negative sign through. So this is going to be 4 minus 5i minus 3 plus 2i. And again, we will collect our like terms. So 4 minus 3 is 1. And minus 5i plus 2i is minus 3i. Okay, so adding and subtracting, not too difficult. Why they call it complex numbers, I'll never know. For multiplication, there is one thing that we just really need to pay attention to, and that is that I squared is negative. So as we look at these examples here, we basically distribute our 2i, and in this particular case, we're going to get 8i plus 14i squared. But remember, I squared is negative 1, and so we're going to write this as minus 14 plus 8i. And it is customary to write the real part before the imaginary part. So not technically wrong to say 8i minus 14, but this is the convention. It's kind of like writing something in descending order. All right, for this next one, we're going to FOIL. So we're going to have 2 times 4 is 8 minus 10i plus 12i minus 15i squared. So 8 minus 10i plus 12i is plus 2i. And minus 15 times minus 1 is plus 15. And in this case, we're going to get 23 plus 2i. Okay. So what you might notice is that when we look at a power of I, of course, I to the first is just I by definition. And by definition, I squared is negative 1. How do we think about I cubed and I to the fourth? Well, I cubed would be I squared times I. And this I squared is negative 1, so we get negative I. And you'll notice I put a little hook there. I don't want to write that and then lose my dot and have it make it look like a 1. So just a tip. Okay, I to the fourth we're going to think of as I squared times I squared, which is negative 1 times negative 1, or 1. And then after that, they continue. So I to the fifth, for example, is I to the fourth times 1 more I, so just I. So it's just going to cycle through. I negative 1, negative I 1. I negative 1, negative 1, negative I 1. So if we want to find any power of I, for example, I to the 13th, I want to find out how many I to the fourths there are. So this is 4, 8, 12, and one more. Of course, these are all 1, so we just get I. The easier way to do that is to say 13 divided by 4 is 3, with a remainder of 1, and this is really what I'm interested in because it's I to the first. So let's see if we can evaluate these here. First, I'm going to distribute I to the 11th plus I to the 17th. We're using the rule that when you multiply the same base, you add the exponents. And then I'll take my I to the 11th and say, well, 11 divided by 4 is 2. That gives me 8 with a remainder of 3. So I to the 11th is like I cubed. 17 divided by 4 is 4. That gives you 16 with a remainder of 1. So we just get I to the first. And then we look up here and we say, well, I cubed is negative I plus I, in this case, 0. Well, let's do that again. I to the negative 7th, if you remember your rule about negative exponents, when you raise something to a negative exponent, you get 1 over that thing to the positive exponent. So this is going to be 1 over I to the 7th, 4, and then I'm just going to go ahead and replace that with a negative 1. I squared is negative 1. All right, let's do 7 divided by 4 is 1 with a remainder of 3. So this is going to be 1 over, and we'll take it from up here, negative I minus 4. Now we'll talk about this one in a minute, but typically we don't have an I in the denominator because remember, I is a square root, and we don't like to have square roots in the denominator. So we'll talk about how we can rationalize when we talk about division. Okay, so let's take a look at what's called a complex conjugate. A complex conjugate are the numbers a plus bi and a minus bi. And when we multiply those together, nice things happen. So if I FOIL this, you'll notice I get a squared minus abi plus abi, and then minus b squared I squared. These two will add to 0. And because this is negative 1, my final result is a squared plus b squared. So notice that I took two complex numbers that had I, and by multiplying them together, I was able to eliminate the i's. So we're going to use that fact when we divide our complex numbers. So for example, we don't want square roots in the denominator. In other words, we don't want I in the denominator because it's technically a square root. So we're going to take this example here and we're going to multiply. We have to multiply by 1 or we're going to change the value. But I want that I to go away in the denominator, so I'm going to multiply by 5 plus 6i and 5 plus 6i. So on the top, if I FOIL, I get 10 plus 12i plus 15i plus 18i squared. We'll simplify that in a moment. Try not to simplify as you go because you tend to make errors when you do that. On the bottom, I'm going to have 25. I know that my outsides and my insides are going to add to 0. That always happens with a conjugate, so I'm not going to worry about that. And minus 36i squared. So simplifying, this is 10. If I replace this with a -1, I have 10 minus 18, so minus 8, plus 27i. On the bottom, I get 25 plus 36, 61. So notice I don't have any more i's in the denominator. Now, if I'm multiplying something and the denominator is not a binomial, it's just a monomial with an I in it, then we can just multiply by I over I. It wouldn't hurt to multiply by minus 4i over minus 4i, but the 4's will cancel. So we're going to get 3i on the top, 4i squared on the bottom, so 3i over -4. That concludes this video on complex numbers. Thank you.